Good morning, students. I am Manoj Kumar, lecturer electrical from Government Polytechnic College, Ajmer. Today we are discussing about power system first, chapter number 7, wind energy. What makes wind? Wind energy is created when the atmosphere is heated unevenly by the sun. Some patches of air becomes warmer than others. These warm patches of air rises up and other air rushes into the replace them and thus wind blows. In this figure we can see that here the warm patches of air is going up and the cool air is replace them, and this makes the wind blows. The wind is a byproduct of solar energy. That's mean we can say the wind energy is indirect part of solar energy. Approximately 2% of the sun's energy is reaching on the earth is converted into wind energy. These surfaces of earth heats and cools unevenly, created atmospheric pressure zones that makes air flow from high to low pressure areas. Wind energy conversion in wind power plants. We can see here the wind input to the wind turbines that gives input to the generator, and generator creates the output of in form of electricity. The wind input is in the form of kinetic energy at the wind turbine blade, and this kinetic energy converted into mechanical energy output of the wind turbine, and this mechanical energy input to the generator and it gives electrical energy at the output. Wind turbines, rotary engine in which kinetic energy is moving fluid is converted into mechanical energy by causing a bladed rotor rotate. That's mean opposite of a fan. Turbine blades spin from the wind and makes energy instead of using energy to make wind. Wind rotates the turbine blade, spin a shaft connected to a generator. The spinning of a shaft in the generator makes electricity. Wind turbine. A wind turbine extracts energy from moving air by slowing the wind down and transferring this energy into a spinning shaft, which usually turns a generator to produce electricity. The power in the wind that's available the harvest depend on the both wind speed and the area of the that's swept by the turbine blades. That means the available wind power is depends on both the factors wind speed and the area swept by the turbine blades. Two types of wind turbines is available here. First one is the horizontal axis wind turbine and the second one is the vertical axis wind turbines. The first one figure is shows here the horizontal axis wind turbine and the other one is shows vertical axis wind turbines. Vertical axis wind turbines. Although vertical axis wind turbine have existed for centuries, they are not as common as horizontal counterparts. The main reason for is that do not take advantage of higher wind speed at higher elevations above the ground as well as horizontal axis turbine. Example of vertical axis wind turbine. These are the both figures shows here example of vertical axis wind turbines. Advantages of vertical axis wind turbine. The generator and the gearbox can be placed on the ground. The structure is usually simple and you do not need a yaw mechanism to turn the rotor against the wind. These are easier for hobbyists to build. Little knowledge of aerodynamics is needed for simple design. Disadvantage of vertical axis wind turbine. These structures are low to the ground where wind speeds are lowest. Overall efficiency is much lower than the horizontal wind axis turbine, and the most vertical axis machines are not self-starting. Their maintenance is more difficult. These are the disadvantages of vertical axis wind machines. Horizontal axis turbine. This is the most common wind turbine design. In addition to being parallel to the ground, the axis of blade rotation is parallel to the wind flow. And some machines are designed to operate an upwind mode with the blade upwind of the tower. In this case, a tailwind is usually used to keep the blade facing into the wind. Other designs operate in the downwind mode so that the wind passes the tower before striking the blades. Examples, these are the examples of horizontal axis wind machines, and here first one, these three machines are horizontal axis machines. Advantages of horizontal axis machines: its efficiency is higher than the vertical axis machines. They are self-starting. They are easier to mount high enough avoid the ground effect. They are less expensive, technology-wise greater, better, and available commercially. Disadvantages of horizontal axis machines is that many of the important parts that require maintenance are high off the ground, and a yaw mechanism must be in the place to turn the turbine into the wind. This figure shows here that the blade is here, and the rotor hub is here, and the gear mechanism is here, and the generator is here. Nacelle is here. The rotor hub provides rotation to the gearbox, and rotation of the gear is provided to the generator moving to produce electricity, which produces electricity is given to the transformer, which step up the voltage and given to the system protector and then sent to the grid. Here operation and monitoring center is also available to says operation status and recording purpose. Parts operating in wind turbines is here. The wind rotor hub is here, and the rotor hubs are connected with the bladeds of turbine. Here the main shaft given here, and the braking mechanism for in case of overspeed, and the gearbox transmission system is here, which help in the required RPM provide to the generator for generating the electrical power. And here housing and tower system also available, high speed shaft system available. These tower are the long as required to the wind power. Is this figure shows the worker are the doing maintenance at the turbine, and this part is called blade, this is called nacelle, and this is called tower. Site selection, basically the site selection of wind power is depends some of the points, just like how good is the wind resources on the site, and how does electricity cost, how much does electricity cost, and there is enough demand for the power, who has site control, and there are potential barriers based on the utility rules, are there permitting joining or other related barriers. Advantages of wind power: the wind is free with modern technology, it can be captured efficiently. Once the wind turbine is built in, the energy it produces does not cause greenhouse or other pollutant. That means it's called a green energy. Although the wind turbines can be very tall, each takes up only a small plot of land, and the excess land is used for agriculture purposes. Many of people find wind farms in interesting features of the landscape. Remote areas that are not connected to the electricity power grid can be used wind turbines to produce their own supply. Wind turbines have a role to play in both the developed and the third world. Wind turbines are available in the ranges of sizes, means vast range, some kilowatt to some megawatt. Disadvantage of wind power: the strength of the wind is not constant. It varies from 0 to strong force. That means that the wind turbine do not produce same amount of electricity all the time. There will be times when the produces no electricity at all. Many people feel that the countryside should be left untouched without this large structure being built. The landscape should be left in its natural form of everyone to enjoy. Wind turbines are noisy. Each one can generate the same level of noise as family car traveling at 70 miles per hour. Many people seeing large wind turbines as unsightly structures and not pleasant or interesting to look at. The disfigure countrysides are generally ugly. When wind turbines are being manufactured, some pollution is produced. Therefore, wind power does produce some pollution. Large wind farms are needed to provide entire communities with enough electricity. For example, largest single turbine available today can be only provide enough electricity for 475 homes. When running at full capacity, how many would we need it for a town of 10,000, 1 lakh of peoples. Thank you.